Good morning, ladies and gentlemen. This is Mr. Smith, and this is 1.28 equations of a parabola. So for equations of parabolas, we're actually given three different forms, and we already know these forms. Standard form, that gives us the y-intercept. That's the c value, so the very last term located right here. The vertex form, which actually gives us the vertex h and k. I know that this was also in the transformations. This is usually what's taught is y equals a bracket x minus h, not plus h, squared plus k. And the reason for this is it's actually easier to determine what the h value is if you have minus h in the brackets here. It translates a little bit easier to the transformations that are given, is what I meant to say. Factored form, we have y equals a, so our a value is out in front, x minus p, x minus q, where our x-intercepts are p and q. Now before we called them zeros, solutions, but they're also just the x-intercepts, and we're actually going to see this demonstrated within the next two lessons. So to actually find the values, or to find the equation of a parabola, we have to use a few different methods depending on what we're given. So if I gave you a vertex form, you have to sub in a value into the vertex form. So sub in values for a point on the parabola to solve for a, your a value. So if we are looking at this example down here, we'll be given an equation that'll look something like y equals a, because we don't know what our a value is yet. That's what we're going to solve. X minus 4, because it went right 4 squared, and then plus our k value, which our k value is just 1 in this case. So we have y equals a bracket x minus 4 squared plus 1. Now to solve for a, we need to sub in some other value. We can either sub in this value here or this value here. I'll choose to sub in the first value, so that'll be our point positive 3, negative 2, it looks like. Yep. So our y value is negative 2. We don't know what our a value is. Our x value is 3 minus 4 there, squared plus 1. So negative 2. We can move the 1 over, and then we'll get negative 3 over here equals a times 3 minus 4 is negative 1. So negative 1 squared. Well, negative 3 is going to equal a, because negative 1 squared is going to be positive 1. Positive 1 times a is just a itself. So we get a is equal to negative 3. Therefore, a equals negative 3. And we can verify this because our first step is actually 1, or 1, 1, 2, 3, down 3. Our first step is down 3. And we know the a value is going to be negative because our parabola is opening down. And just looking at this, we can see that the graph matches our algebraic expression in this. Now, you won't always be given a graph, so being able to count out the first step won't always ring true. I could also give you a graph that isn't a parabola. That'd be a cruel trick, but it's possible for that to happen. So just keep that in mind. Find the equation of the quadratic relation that has a vertex 2, 3. So remember, this is our h and k value. And has a y-intercept of negative 7. Well, if it's a y-intercept, then that means our x value is 0, right? Because it's on the y-axis. So it's 0, negative 7. So we're given 2 points here. We're given the vertex, which is incredibly useful. We get most of our vertex form from that. And then we're given another point, so we can actually solve for a, just like we did before. And in this case, we can't actually just look at a graph and solve it that way. So this is where that strategy of looking at your step pattern will not help you. So we have x minus 2, because it's minus your h value, plus your k value, which is 3. Then we sub in one of our points. Well, we know the point 0, -7. So we sub in -7 for y equals a times 0 minus 2 squared plus 3 at the end. If we move the plus 3 over, we'll get negative, so we'll get -10 over here. And then -2 squared is 4, so we get 4a. So a equals 5, -5 over 2 when you reduce it down. Therefore, your equation is y equals -5 over 2 x minus 2 squared plus 3. And what's fascinating about this is your a value is a fraction. So being able to count out your step pattern might not actually work that nicely here, because fractions are very difficult to count on a graph. So that's why you need to know this method. Okay, next slide. Finding equations given the zeros. So if you're given the zeros, you can use in your factored form. So if you sub in the values for any point on a parabola, then you solve for a. So in this equation, or in this graph, or this example, I don't actually give you the formula. That was something that I just revealed early on, just so that it's nice and computer generated, because it's nice and neat. But we can clearly see that our zeros are here and here, right? So our zeros are -2 and +3. Notice how the signs are switched, because remember, your zeros are the values you'll sub into each bracket. So if you subbed in -2 into this bracket, the first set of brackets, you'd get 0 in there, hence the name zeros. If you subbed in +3 into your second set of brackets, like right here, you would get a 0 again. And no matter what you multiply out, you'd get 0. That's why they're called the zeros, or the x-intercepts in this case. So now we know these two x-intercepts. We can look for a point. Our vertex doesn't look super great. If we look at our vertex here, it looks like it's some sort of fraction, so let's not go with that. We could go with either the positive or negative points that we know. So I'm going to go with the point 2, 6 here. Now I sub in 2 for the x values and 6 for the y value. So I'll end up with 6 equals a, 2 plus 2 times 2 minus 3 here. So I still have 6 equals a, 4 times -1. So 6 is going to equal -4a. So we'll end up with 6 over -4 equals a, which is just -3 over 2 equals a. So our final formula, therefore, our formula is y equals -3 over 2, which this checks out because our a value has to be negative. We know that because if we look at our parabola, it opens down. So -3 over 2, x plus 2, then x minus 3. Perfect. All right, let's move on to the next example. Final example, find the equation of a quadratic relation that passes through these 3 points. Well, it looks a little bit more challenging than you would think, but if you were to graph those points out, you would see very clearly that you'd have -1 over here and then like -5 further over here. So automatically, we know that this parabola has 2 zeros. So this is a 0 here. This is another 0 here. And then we have some point which is -316 somewhere around here. We don't know if it's the vertex or not. You could determine if it's the vertex if -3 is exactly halfway between -1 and -5. That would be where your vertex is, because your vertex is always halfway between your zeros if you have two zeros. In this case, let's assume we don't know that. So we do know our zeros. Our zeros are -1 and -5. That means that when we sub them into the brackets, we need -1 to give us 0 and -5 to give us 0. So our equation should equal a, because we don't know our a value yet, x plus 1 instead, and x plus 5 instead of -5. Because when you sub in -1 for x, you'll get 0. And if you sub in -5 for x, you'll also get 0. So this still works. We just don't know the a value yet. Now we use our third point that we know that is on this parabola, -3, 16. We sub in -3 for the x values and 16 for the y value, just like we did before. So -3 plus 1 in this first bracket, then -3 plus 5 in the second bracket, and we just solve like we did before. So -3 plus 1 is -2, -3 plus 5 is +2. So you'll have -2 times +2, which will give you -4. I am jumping a little bit. 16 divided by -4 will just give us -4 equals a. Therefore, our final equation here, it doesn't say what form of the equation that you need. It just says find an equation. And there's 3 different forms, as you guys are well aware of. So it's -4 for the a value, and then x plus 1 and x minus 5. And that is your equation. And that's everything you need to know for 1.28. If you have any questions, make sure you post them or ask. I think that you guys are starting to get the hang of everything here. We combine factoring, vertex form, completing the square, kind of all together towards the end of this cycle. We got one more lesson in this cycle. So best of luck, and I'll hear from you guys soon.